I recently did a lightning talk in the Pecha Kucha format about machine learning as simply as possible. And because making a bunch of slides was kind of boring, I made a GitHub site called Lightning Talk Pecha Kucha Tensorflowjs. It's on GitHub. And I'm just going to make a video of it. Here's how the page shows up. So you could go into that one and change the index.html and change all these slides and actually record your voice. So here's what it's got. It's got a starting one that every 20 seconds it switches the slide. This one stays, and one similar to it shows up at the end. Normal sound, mellow sound, intense sound. So what I'm going to do, I'm just going to play this and see how it goes. So
Jeremy Ellis here, machine learning using single file web pages and the Tensorflowjs library. My Twitter is @Roxetta, website www.roxetta.com. I've been programming for years and making things simpler. Probably best just to ignore me and go to www.roxetta.com/TensorFlowJs and look at the whole set of example programs. I give minimal comments. They tend to overwhelm my students. So this is what I got. First of all, I'm not really interested in high-level information about machine learning, cryptocurrencies, coding, robotics. What I do is simplify. Take something complex, make it as simple as possible. Get rid of probably the CSS and just working in JavaScript. That's what I do. So Atwood's law says basically anything that can be done in JavaScript will eventually be done in JavaScript. I was really sad in 2015 when TensorFlow came out and it was all Python and C++. But 2017 TensorFlowJs comes out. Awesome. Now you can use machine learning in web pages. The only gotcha I got is I've taken the typical script tag, which is static, it loads once on a web page, and changed it to a style onload equals tag. And all my functions are in there so that they're global for the whole page. This allows you to look at the code, edit it, and run it. All these pages, all these examples have information at the start in this kind of blue surrounded box where it describes what's happening on that page. As I've said, the black box shows your code. You can edit it and rerun it. So there we go. You've got your TensorFlowJs version button. Click on that. It tells you the version. Click on the see the working code. It shows you the code, and you can edit it. So edit that code, click update and run, and see how it works. That's what this is all about. So I've got a whole ton of examples, actually 78 or more. But the red arrows are at the ones I'm going to be looking at the moment. The Kira's layers XOR is probably the simplest one I can come up with. So that's where we're going to start. So Kira's layers has two inputs. If they're both 0, your output's 0. If they're both 1, your output is also 0. If either of the inputs is 1, your output is 1. That's the XOR format. Running 3,000 epochs. I've got pretty much those results. You can see them right there. So the code, all this code's in similar format. So here we have the model. We're adding input shape of 2 inputs. For that first layer, it goes to 10. The second layer takes the input of the 10, and it has 1 output. We're going to train that with SGD. Next, we're going to set up the data, very simple amount of data in this, and then we're going to call the fit function with that data, with some parameters, and a callback function. This is going to happen 3,000 times, training this model, this quite small model. But all of these are similar. The next part's quite large, actually. We do a predict into a myPredict array, and this is all output. Outputting to your web page using inner HTML. You're showing what you're outputting, and you're grabbing one of those array outputs. That's it. Most of these programs are similar. So here's a quadratic where we're actually training a model to do a quadratic. Not really interested in the information here. This is more about the web page. The lower box there shows you how you can change those parameters dynamically by the user on a web page, quite easy. Then a lot of these examples have a full web app if you go down past the basic example. So you got parameter entry, you've got your XY data entry, you can load the data from a file, you've got your model, you've got your training, you've got your output, and you've got model saving either locally on the web page or to a file. Images are really quite difficult because images have a lot of data. So what I've done is I've reduced it to black and white. So we've got ones and zeros, and this model is trying to identify how many lines you've got, straight lines. So in this one, it's got 2 lines, and it identified with 50% accuracy. Next, one-hot encoding, really important to learn one-hot encoding. So here we've got an elephant, one-hot species, 10000, and the one-hot class, 100. And I've got all that information there, plug it into a model, and identify a crow. It comes out not great, but it works. Now let's do some advanced Keras. So we've got multiple inputs now. You're getting 2 different types of inputs concatenated into a model, and multiple outputs. You've got your one model, and it has a quick output, and then it has a more complex output. That's pretty advanced stuff. So much easier just to use pre-trained models. Here I'm loading a model, I'm activating a webcam, I'm auto taking a snapshot every 1000 milliseconds, which is 1 second, and it's reasonably accurately identifying TV remote, 91% as a remote control. I use posenet.js quite extensively. What we have here is an example of a toy car using a cell phone and a WebSocket to communicate. If I raise my arms near my shoulder, car goes backwards. If my whole body is on the left, car turns left. Right, far away, car goes faster. And that's it. Have a look at the site. Machine learning made easier by using single file, Tensorflowjs. Keep in touch at Roxetta. I'm also working on Gitpod, Get Capacitor, cryptocurrency IOTA, particle robotics devices, and most of this is all in JavaScript. Have a good day.